In the last lecture, we have discussed about the another technique of data analysis, fitting of the curves. Okay, so what we have seen, we have started with the equation of line. Okay, then we have seen how to we'll get the normal equations using the method of least squares. Okay, so using the method of least squares, we are able to get the normal equations for the first degree curve, for the second degree curve, as well as for the higher degree curves. Okay, and then we are able to fit the line or the second degree curve. We call it a parabola. Okay, so let's have some examples based on this. Okay, so let us see the examples based on this. Okay, so first we'll consider the fitting of a straight line. What this straight line is called the first degree curve. Okay, so we have to fit a straight line or a first degree curve. Okay, so let us see how we are able to solve the example based on this. So let's have the example. So now this is the given data, and we have to find a line, best fit line to this. We have example one. Fit a straight line for the following data. So the data is given x, y, x is equal to 3, 4, 5, 6, 7, 8, and you can see the y observations as 8, 6, 5, 7, 6, 4. Okay, so we have to fit a straight line to this. Let us start with the solution. Okay, so what we'll be having, first we need to write what is the straight line. Okay, so let y is equal to ax plus b, this being the straight line. Okay, so what we know is once we know what is the straight line, then we are able to write the normal equations. So the normal equations are, what is the normal equation? So what we have to do is take the sum of this. So y is equal to a summation x plus nb, and then what we have, multiply this by x and take the sum. So multiply this by x and take the sum. So x summation xy, a summation x square, b summation x. So this is equation 2. Okay, and now what do we have here? N. N is the number of observations. So how many observations we have here? We have 6 observations. So we can write here where N is equal to number of observations. So here what we have here, N is equal to 6. Okay. So you can see if I want to fit this line, I have to solve this equation. And if I have to solve this equation, what are the terms needed? I need to know what is summation y. I need to know what is summation x. N I know. I need to know what is summation xy, and then I want what is x square will have. Okay, so these are the terms 1, 2, 3, 4, and 5. So 5 terms we need to know, but this one is easily you are able to calculate and get it. And this 4 terms, for this 4 terms we have to make the table. So let us make the table for this. Okay, and hence what we can have is, consider the following table. Okay. So what is the table that we have to consider? These four terms. Okay. X, Y, X into Y, and then X square. So we have here, this is going to be X, Y, and then uh, square. So we got here X, Y, X into Y, and we want X square. Okay. So these are what the terms we have to consider. Okay. Then we have here uh, number of observation plus one. We have to make the rows. Then columns already we have decided. Okay. So columns can, what are the columns that we need can be obtained from the normal equations, and that's why first we have to write the normal equation. So if you write the normal equation first, then easily you are able to get columns. What columns you need to consider. So now we are interested in summation of all these columns. So see the observations what we have here. So for x we have 3 to 8. So x is going to be 3, 4, 5, 6, 7, 8, and this is for the summation. Okay, so what you can have this is going to be is it 33? So check your calculations. Okay, then what we want next? We want this 8, 6, 5, 7. So we have 8, 6, 5, 7, 6, and 4. Okay, so these are the observations we have. And now we want a summation of this. So I have the calculations. So this is going to be 24. Going to be again 24. This is going to be 25. This is 42. This is 42. And this is 32. So give me what is sums you are getting. So x square I want. So this is going to be 9, 16, 25, then 36, 49, and 64. Okay. So how these sums? What are the sums you are getting? Okay. So what is summation y? What is going to be summation y? Summation y is 36. Okay. Good. So I have summation y is 36. What about summation xy? X into y. What you are getting x into y? Please check. Okay. So x into y you are getting 189. So it is going to be 189. What is summation x square? What you are getting x square? 199. Okay, that's great. So you are getting this is going to be 199. Okay. So you got all the summations here. Okay, and now see, if I have this all the summations, summation x, summation y, summation x into y, and x square, and I obviously know this n. So we are able to put these values here, and then we are able to solve this equation. Okay, so from above table and equation 2, we have normal equations as. So what are the normal equations you will get? See, I am writing this in terms of now as we usually write the linear equation. So this will be summation x times a and n times b. Okay, so n is equal to 6. So what we'll get is 33a plus 6b is equal to summation y. So it is 36. Then what do you have next? X square. So 199a plus 33b summation xb is equal to summation xy. So what you'll be having 189. So you can see these equations I have written in this form so that it will be easy for us to solve. Okay, if we write in this form, then you may get confused or you may not enter the proper equation in matrix form, and so you will not get a proper solution. That's why we should write in a proper way so that we can get the correct solution. Okay, and hence I can write here solving above equations we get. So what you are able to get here, see, so you are able to get A is equal to and B is equal to. So you have to get up to 4-digit accurate. Okay, so you have to tell me 4-digit after the decimal place. Okay, so please tell me what are the value of A and B you are getting. So A is minus 0.5142. What about a B? B is 8.8285. So please, yeah, check your values. So A we got as A we got minus point minus 0.5142 and B we got 8.80 got here 8.8285. 8.8285. And now what is the equation of line we have decided? So equation of line is y is equal to ax plus b. So we have to put the value of a and b here, and hence we can write. So we got the value of a and b. So we can write here from equation 1 we have, so what we have, y is equal to minus 0.5142 times x plus 8.8285. Again, and now we have to we got this equation, but we have to check whether this equation is correct or not. Whether we have obtained is correct or not. So what you have to do is type this equation in your calculator, okay, and calculate the value of y for x is equal to 5. Okay, so calculate the value of y for x is equal to 5 using the final equation that we have obtained. So use this equation and calculate the value of y when x is equal to 5. Just give me the answer what you get. So what you are getting 6.275. Okay, that's great. Okay, so actual value is 5. Okay, you can see at 5 at x is equal to 5, y is equal to 5. You can see here the given data. Okay, so in the given data you can see at x is equal to 5, y is equal to 5. Okay, but what we are getting here at x is equal to 5, we are getting y is equal to 6 point something. Okay, so that means this line that we have got is not exactly very correct, but it is the most correct line. Okay, this is not the exact line, but it is the best approximation to the line. Okay, and that's how we have to find. And you got here slope is going to be minus. You can see why the slope is minus. You can see here the data. Okay, so see x is increasing and y is decreasing. Okay, so 8, then 7, then 4. So slowly y is decreasing. You can see here 8, 6, 5. This was these 2 points were out of the line. So x y was 8, 6, 5, and then it goes to 4. That means y is decreasing while x is increasing. And if this happens, then the slope is going to be negative, and that's why we got the slope is to be negative. Okay, so this is how we are able to get the equation of the line using the least square method. So here we have used the method of least squares. So do you have any doubt in these calculations or in this example? What does the line indicate? Yeah, what does the line indicate? What can we infer from it? Yes. Okay, so what we are doing, we are trying to find the relation between the attributes. Okay, we are trying to fit a model. Okay, this is a regression model. Okay, as I say, in the earlier data also we have fit the regression model. In the regression model, when we want to find out the value out of the range, okay, then it becomes predictive model. When we want to find the value inside the range, okay, then it becomes data cleaning model. So we clean the data, or we find the missing figures, or we check whether the data given is tampered or not. Yeah, so that are the techniques which are used actually. Here, what we are doing is we are finding the line means we are just building the model. Okay, so when we want to find some value within the range, then it is data cleaning. Out of the range, then it is predictive model. Okay, so here we are trying to find the linear model for this data. Okay, using the technique. Now technique we have changed. Okay, so earlier we have used the regression coefficient and correlation coefficient and that all. So here we will not go for that calculation, but here we'll go for the method of least squares. Okay, so here what method we are using is the method of least squares. So when we don't want to analyze what is the correlation, is there any correlation? Okay, these things we don't want, then we use this model. Okay, if I want to know what up to what extent my decision is correct, then I have to go with the correlation. Okay, so here I am not bother about my decision whether it is or what it is, how much it is correct. Okay, so that's why this is directly. Okay, it is same as what we used to do in regression. So this is again a regression model. Okay, but here using this method, we will go for non-linear also. Okay, so we are finding the relation between the two attributes, same thing. Okay, but the technique is different, and this technique can be extended to more curves. Okay, earlier technique cannot be extended to more curves. So this was a drawback with the earlier technique, that we were not able to extend it to non-linear. That was limited to linear. And this technique now what we are learning, the method of least squares, can be extended to any degree. That is the benefit of learning this technique. Okay, hope I answer your query, Gaurav. Correct? Curve fitting is actually we are building the linear and non-linear models. Okay, so we are just modeling, or we are finding the model what data follows. Okay, in the language of mathematician, we are just fitting the curve. But when we consider as a computer scientist or as a data analyst, we are building the models actually. Okay, what models data is following, or we are testing the data for the models. Okay, so that's what we have. So the meaning of curve fitting in mathematics and the meaning of curve fitting in applied way, okay, or in the subjects like data analysis. So mostly these are used in, see, the basic thing is the data analysis. Then we feed this to machine learning and AI. Okay, so when we want to make the decision, then this AI will work. Okay, so first I need to model that model to be fitted to a machine, and then after it is given to machine, then the AI will take the decision. So these are the steps that you have to follow. So first, try to understand the basic of mathematics, how we do it. Okay, then apply it to the subjects. Okay, like first basic data analysis, and then we feed it to machine learning, and then we feed it to AI. So then once the AI can take the decision, it will ask the machines like we have VSM, virtual support machines, and all. So they will take the decision. Okay. So that's how this is the base to decide what we have to do, or whether we can do it or not. And if we can do it, what is the level of confidence? Okay. So this is what we are learning now in applied manner. Okay, in mathematical way, we are finding the equation, but that equation is not just an equation, it is the model actually for applied people. Okay, so when we think of applications, it is a model. Okay, when we think of the mathematician, it is just the equation. Okay, so let us go for the next example. Yeah, that's good. Okay, so we'll go for the another example. Okay, so we have data, meteorological data now. Okay, so this can be any data. Okay, so now you can see we have meteorological data, and what data is given? The amount of rainfall. Okay, and the quantity of air pollution. So here we need to understand whether the this data can be considered. Okay, so here we have the study of rainfall and the quality of air pollution. So what kind of air pollution is removed if we consider the amount of rainfall? Okay. So here what we have collected a data, and now what is given to us, we have to find the relation, okay, for the data, the air quality, what air pollution will be removed, and what we have if the amount of rainfall we have. Okay, so now let us see this. Okay, so what we have here, you can see the amount X, 3.3, 3.5. Suppose this rainfall usually measured in millimeter, centimeter, okay, and like that. So suppose this is in centimeters, okay, and then the quantity of air pollution removed, okay. So if there is 3.3 centimeter rainfall, then the air pollution removed is 11.6. This air pollution is measured in parts per million. Okay, so it is parts per million. So what we have, this is in centimeter, and this is in ppm. Okay, so parts per million. Okay, now this parts per million, you might have seen. If you have gone for your vehicle to the PUC, taking the PUC, pollution under control. Yes. Okay. So when you visit this EUC center, okay, all measurements are in terms of parts per million. Okay, so we measure it as ppm, and then they measure the quantity of the different gases emitted. Okay, when your vehicle is on, so there is a limit that it should be up to that. But if you see, we drive so many vehicles, and collectively it affects the air quality. Okay, and the quantity of air pollution is we can say directly proportional to the number of vehicles we use. Okay, and now when there is a rainfall, okay, what happens? Some particles of this pollutants, okay, are carried with these air drops. Okay, and now this data was collected. Okay, so what is the rainfall, and then how much quantity was removed. Okay, so the quantity measured before the rainfall and the quantity measured after the rainfall. Okay, and the difference is given to us. Okay, and now we have to find the linear relation in that. So in mathematics, we have to fit a line. In the applied way, we have to build a regression model for this effect. Okay, so in applied way, what we are doing is we are building a regression model for this effect. Okay, so this is the climate effect, this is the meteorological data, and then we have to build a model. Okay, so we'll think how good model we can build. Okay, so let us build this model. Okay, so what we have here, we have given, so we'll go with the solution here. Okay, so what we'll be having, let y is equal to ax plus b. Okay, this is one. B, the straight line for the data, the amount of rainfall, x, and the quantity of air pollution, y removed. Okay, so this is the line we are considering. Okay, now what we have to do is once we consider the line, we have to write the normal equations for that. So we can write the normal equations are given as. So what are the normal equations? Summation y, sum of this first, a summation x plus nb. Then we have multiply this by x and have the sum. So summation xy, a summation x square plus b summation x. So this is equation 2. Okay. So what is n here? Because x and y we know, we don't know about n. So where n is equal to number of observations. Yeah, so here we have the number of observations, and then what is the value of n here? So here n is equal to, count the number of observations. How many observations are given? 1, 2, 3. So we have the 8 observations, and here n is equal to 8. So once we got this, what we have to do is we have to construct the table. So what we are having here, consider the following table. Okay. So what do we want here? We want x, y, then x into y, then we want x square. So always for the line we have to consider these parameters. So what I want x, I want y, then I want x into y, and I want x square. Okay, so these are the things which we require. Okay, and we have 8 observations here. So I hope you are calculating with me. So please make the table. It will be easy for you. So we are given x, we are given y. We want to find out x into y. Then we have to find out is x square. So we have to calculate this table. Okay. And here we have summation. Okay. So I want you to calculate this table now. Okay. So once you are ready with the table, then we'll see. So hope you are calculating the table with me. I am also calculating. Okay. So if you are done, you can with me? Yes. I hope you are ready with your table. Okay. So I hope you got the table. You got the table. You got all the values. Okay. Just check with check your calculations with my calculations, so you can get the correct idea. Okay. So here we have n is equal to 8. So consider drawing table. So we got the table here. So I hope you got the same. Okay. So this is x, this is y, this is x into y, and this is x square. So have you got the same values? 29.5, 90.6, and this. So got some more values. So what? So check your calculations. I hope this is correct. Okay, only the problem is here. Okay, is the same? Yes, it's the same. Correct. So good. Great. Okay, so once you got these calculations, okay, what we have to do next? We have to write this equations. Okay, and then so what we get here? So from above table and equation 2, we have the normal equations as. So what will be the normal equation? See, these are the summation. So this is summation x, this is summation y, this is summation x into y, and this is summation x square. So we have the normal equation. So normal equation is summation x a time. So 29.5 times a plus 8 times b is equal to summation y. So 90.6. Then we have summation x square times a. So 121.01 times a plus 29.5 times b is equal to summation xy 325.72. Okay. So once you get this equation, so we can write solving above equations we have. So what you will get is a is equal to and b is equal to. So what are the values of a and b you are getting? A is a is going to be negative. Are you getting a to be negative? Okay, so a is minus 0.6842. So a is here minus 0.6842. And what about b? It is 13.8481. Okay, so 13.8481. So here we got the value of a and b. And hence what we can say is from equation 1, we have y is equal to 0.6842 x plus 13.8481. Okay. So this is the equation. Okay. So we can have this is the equation of straight line. Okay. So what this line suggests, what this model suggests. Okay. Here slope is going to be negative. Okay. Slope is going to be negative. That means if you remember, r is going to be negative. Okay. So slope is negative. That means r is negative. R is negative means so we cannot guarantee that there is a relation or not. So you can see at lower rainfall, you are having higher removal of the air quantity of air pollution, and at the higher rainfall, you are having lower removal of the quantity of air pollution. Okay, so that means we cannot guarantee that there is a relation, because at 3.3 it is going to be 11.6, at 4 it is going to be being less, at again less it is going to be more, and more or less it is going to be. So here what kind of relation we can say the r is going to be negative. So we confidently cannot say. So may possible that here the air quantity, air pollutant may be less in air present, so that it is removed less. So here it may be more, and so it may be removed more. Okay, so that means here we cannot guarantee, but what is the relation that we got? We got a relation with this, and that's why this is the model we got for this data. Yeah, so if we want to use it, we can use it. If we don't want, then we can discard. As we know, the R is going to be negative, the slope is going to be negative. So that means less rainfall, more removal of the quantity. But do you agree that it may be true? Less rainfall, more removal of the quantity of air pollutants. Do you agree? Or do you think it may be feasible? Correct. So otherwise, then if there is no rainfall, that means all the air pollution will be removed. Okay. So this way, when we get the data, okay, so we have to test whether it may give you a good result or not. Okay, and then when we set or when we find this kind of relation, that gives you the idea whether our assumption or whether this experiment gives you some feasible reasons for feasible solutions or not. Okay, and that's why in this case, the model is not a good one, or the parameter we have considered are not proper. Okay, and that's why if we want to, we are going for the analysis of the pollution, air pollutant, or the quantity of air pollutant, then this is not a good model. Okay, so we have to search some other parameter. Okay, so that way we can think one more. Okay, so we'll try to have one more examples. Okay, so we'll consider one more example, and so let us have the another example here. Okay, so we have the example. Fit a straight line to the given data. The data is given here x and y, and this was a university question asked in the December 19. Okay, so let us try to solve it. So we go with the solution. What we have, that y is equal to ax plus b. Equation 1, b, the straight line. Straight line. Okay, so we have the normal equations as. So what are the normal equations we are having? So it is going to be summation y is equal to a summation x, a summation x plus nb, then summation x into y is equal to a summation x square plus b summation x. So this is equation 2. Okay. Now what we have here? So here where n is equal to number of observations, and here what is the value of n? So see the observations. How many observations you have? 5. So we have n is equal to 5. And once we know what is the value of n here, so you can write the table. Okay. So what we can do is consider the following. Okay. So now you know what is the table you have to make: x, y, x into y, and x square. Okay. So you have to make this table and then find the summation. So we are interested in all these sums. So I want you to write this table and then calculate the summation. Once you get the summation, we'll see your calculations and my calculations. So calculate this. I hope you are calculating with me. So if your calculation is done, then we can have the values. Okay. So is your calculation done? Okay. So good. Let us check your calculations with my. Okay. So I hope you are able to get this one. Are you able to get the same? Yeah. Okay. That's great. So that means you are calculating in a correct way. Good. Okay. So once our calculation is done, our table is ready. Then we are able to find or we are able to solve the normal equation. So let us solve the normal equation then. Okay. So what we can write is from above table and equation 2. The normal equations are. Okay. So what are the normal equations we get? See, these are all the summation. So this is summation x, summation y, summation xy, and summation x square. And moreover, we have already declared the value of n. So n is going to be 5 here. Okay. So what are the normal equations we have? So we have a summation x. So it is going to be 80a plus 5b is equal to summation y. So that's going to be 100. Then we have x square a. So 1398a plus 80b is equal to summation xy. So 16 and 84. So what we can do is we can solve this equation. So solving above equations we have. So what we'll get here, we get a is equal to, and we have a is equal to. So give me the value of a and b. We cannot have two different values, Rohit and Pooja. So let us see whose calculation is correct. Okay, so Mukul got this one. What about Rohit? What your calculations are? Calculating properly. So if you miss, Gaurav got this one. Okay. So I think Rohit has calculated some entry to be different. You got the same summation values, then why your values are going to be different? Okay, everybody is getting the same. You are having some different values. So please check your calculations or your calculator. You need to reset them. Okay. So we got A is equal to 0.7118. Okay, so we got A is equal to 0.7118, and we got B is equal to 8.6101 of 02. That's okay. So we got 8.6101. 8.6101. So we accept these values. Okay, 01, 02 is okay. That's not a problem. So one digit, and that is it is 10 raised to minus 4. So we can have it. So then we can write the line of we can have the straight line is one as. So what is the straight line you will have? See, y is equal to 0.7118 times x plus 8.6101. Yeah. So this is the equation of line we can have. So hope you are getting the same value. So I hope you are getting the same value now. Okay, great.